Our I can statement for today is I can apply properties of operations to rational numbers. We watched some videos in class and then answered some questions. I will not be going over those portions of the notes in this video because you had to watch those other video clips to respond to those, but I will be posting those videos for your viewing as well. In your notes, take a moment to record the definition of commutative property. Changing the order of addends does not change the sum. And then pick either this or this version as an example of the commutative property. If you do well with abstract thinking, if working with letters and numbers makes sense to you, the first one is the most general form. But if you like concrete examples, the second one with specific numbers might be more helpful to you. And if you'd like, you can also draw in these picture examples as well. You can pause the video after each slide if you need more time to write things down. All right, for the associative property, go ahead and record its definition. The order in which numbers are grouped does not change the sum. And once again, you're going to pick either this or this as your example. You can also draw in the picture if you'd like. The third property, the distributive property, is one we haven't really talked about quite yet, but you can go ahead and write down the general formula here. Okay, it is A times, in parentheses, B plus C equals A times B plus A times C. Now, if we take a look at our example here, we could have computed this original problem by following order of operations. 3 plus 9 gives us 12, so we can rewrite this as 4 times 12, and 4 times 12 gives us 48. We could have done that, but we can also see that if we do 4 times 3 plus 4 times 9, we end up with 12 plus 36, which is also 48. Now, why do we care about this example? Why is this important to us? Well, sometimes one of the numbers inside the parentheses won't be a number. It might be a variable like x or y, like we see in this example over here. And so being able to use the distributive property can help us to clean up, reorganize, and find a final answer much quicker because we wouldn't have been able to use this previous example off to the side. Okay, so the distributive property is going to be super helpful, especially once we start our equations in our algebra unit. Here's a visual example that you can take a look at. Okay, we have the same number of cubes whether we do 4 times 3 plus 2, or if we do 4 times 3 plus 4 times 2. So that's a visual example we can see. Do a quick check, name each property, and then pause the video or start the video up to check your answers again. All right, part A is commutative, part B is associative, and part C is distributive. The first one is commutative because the numbers are commuting. The second one is associative because the groups are changing. The last one is distributive because we distributed the 6 to each number inside. So remember that we could look at the root of a word to help us to remember the definitions. So the root of the word commutative is commute. And you might have heard your folks, your parents, or adults talking about how they have to commute to work, right? So commute is a word that indicates movement. So you can use that to remember that the numbers move around. Okay? The associative property, its root word is associate, okay? And associate means to group together So sometimes you might associate with one group of friends, sometimes you might associate or group together with another group of friends. So when you see associative, think of the groups or the parentheses moving. And finally, with the distributive property, the root is to distribute. And so that can remind you that we distribute or give the front number to the inside numbers. So we multiply the outside number by each of the terms inside the parentheses. Okay? So distribute means to give. Okay? So those can help you to keep track of the different words and what they mean. Now, the information here in this graphic organizer isn't new. It's just a kid-friendly summary of the 3 different properties. So you can go ahead and fill these in on your notes. So for the commutative property, it means the numbers move. For the associative property, it means the parentheses move. And for the distributive property, it means everything inside is multiplied by the number outside. And here are some of those general examples. So you can use this graphic organizer as a study tool. Pause the video to record the information you need. Now, an important thing to note is that these properties work for multiplication too. So here's some examples of the commutative property. 3 times 4 is the same as 4 times 3. They both equal 12. Okay, for the associative property, 2 times 3 is 6, and 6 times 4 gives us 24. 3 times 4 is 12, and 2 times 12 is 24. With the distributive property, nothing changes because the distributive property uses both addition and multiplication, so the problems will look exactly the same. Now, these problems don't work for subtraction, but remember, like we saw in the video, as long as we take the sign with us, we can make the commutative property work for us. So, for example, 2 minus 3 is not the same as 3 minus 2, because this would be -1 and this would be 1, so they aren't equivalent. However, if I keep the sign with the number, I could rewrite this as -3 plus 2. So this is how the commutative property can work, because we can change this to plus -3, and then we can move the negative with the 3. So that's how the property works for subtraction. However, we'll see that the properties do not work for division. So the properties don't work for division. Here are a few examples. If I do parentheses first on this first example with distributive, I can see that 1 plus 2 would be 3. And then 9 divided by 3 gives me 3 as a result. However, 9 divided by 1 is 9. 9 divided by 2 is 4.5. 3 is not equivalent here. Okay? This would be 13.5. So those are not equal. With the commutative property, 9 divided by 3 would be 3. 3 divided by 9 would be 1/3. So these are not equal. So the property doesn't work for division. With associative, we would do parentheses first. So 16 divided by 4 would be 4. And then 4 divided by 4 would give me 1. However, over here, if I do 4 divided by 4, that is 1. And 16 divided by 1 is 16. So these two are not equal. So always remember that distributive property does not work for division. And I should take a moment to point out this is the not equals sign. Okay, so if you see that, that simply means that the two expressions, the two statements on either side, do not equal each other. Take a moment and answer these questions, true or false, and then start the video to check your answer. All right, now here's how we show evidence of our answer for number 18. 3 minus 2 would be 1. 2 minus 3 would be -1. So the statement says 1 does not equal -1. This is a true statement. So they're not equal, but that's what the statement says, so that's why it's a true statement. Okay, with the next statement, I can see right away that this is negative and this is positive, so these can't be the same. But we can go ahead and compute it. 3 minus 4 would be negative 1. 4 times negative 1 would be negative 4. And 12 plus 16 we already know is positive, so it definitely can't be the same answer. 28 and negative 4 are not equal, so this is a false statement. Finally, 12 divided by 3 would be 4. 3 divided by 12 would be 1/4. So these are not equal, so this is a false statement. Here are some bonus problems, true or false. 3 plus 2 equals 2 plus 3. This is true. It is the commutative property of addition, and it's totally fine because they're both adding, and we just switch the order. 3 minus 2 is equal to 2 minus 3. This is false because we needed to move the sign with the 2 in order to use the commutative property. The first example is 1. The second example is negative 1. All right, there are 9 examples of the different properties: commutative, associative, and distributive. See if you can identify which property is represented with those 9 examples. Start the video up when you're ready to check your answers. All right, let's check our answers. All right, here are the answers. So 4 plus 3 equals 3 plus 4. The numbers moved, so this is commutative. 3 times 5 is equal to 3 times 5 times 5. Notice I have the same numbers. The only thing that's changing are the groupings, so that's associative. 2 times the quantity of 4 plus 12 equals 8 plus 4. We can see that this is equivalent to 2 times 4 plus 2 times 12. This is distributive. 24 plus 18 equals 3 times the quantity of 8 plus 6. 3 times 8 is 24. 3 times 6 is 18. So this is an example of the distributive property yet again. It's just the two sides of the equation are switched from what we've seen before. The next one is also distributive because I have 5 times 3 plus 5 times 6 written out on the other side. 10 times 5 equals 5 times 10 is commutative because just the numbers are mixed up. 6 plus 25 plus 4 equals 6 plus 25 plus 4. This is associative because the only thing that's changed is the groupings. 2 times 8 equals 8 times 2 is commutative because the numbers changed. And 6 plus 8 plus 4 equals 6 plus 8 plus 4. The only thing that's changed is the groupings, so that is the associative property. All right, try these last 2 true or false problems. All right, 3 minus 4 is negative 1. 4 times negative 1 is negative 4. 12 plus 16 is 28. These are not equivalent, so this would be false. If I do parentheses first, 2 plus 1 is 3. Then I have 5 plus 3 is 8, which is not equal to 7 plus 6, which would be 13. And I want to point out why this one is false, okay? They tried to distribute with addition, okay? 5 plus 2 is 7, 5 plus 1 is 6, but they are not equivalent. So that's another important thing to remember. Watch the video as many times as you need to review, pause when you need to, and thanks for watching.